Hello friends, welcome back to this online lecture series on structural failures and repair. As you know, in this particular subject, we are discussing on the different aspects regarding the construction industry, wherein in the previous units, our focus has been on the different types of topics such as the construction failures. Along with that, we have seen the durability of the structure or the durability of the concrete also. In that, we have seen in detail the different types of durability, that is the physical durability as well as the chemical durability. From today onwards, we are going to start with a new topic, that is the cracks in concrete. Now, when we talk about cracks in concrete also, in this particular lecture, we are going to cover the basic classification of cracks, that is based on the structural aspect also and based on the construction aspect also. And once we have discussed this basic classification, that is based on the structural aspect as well as the construction aspect, then we will go into the detailed discussion of these different types of causes of cracks, and we will also try to see the phenomena that results into the cracking of the concrete, and at the same time we also discuss the causes and the preventive measures that can be taken to reduce the cracks in the concrete. So let us start today's session with the very basic definition, that is the definition regarding the cracks. Now, what is basically a crack? So, a crack is a complete or an incomplete suppression of concrete in two or more parts, right? That is produced by breaking or fracturing, right? So, it may result either from breaking, it may result either from fracturing. There are several reasons for the distress in the concrete, which are going to cover in the upcoming lectures also, where you will try and see and you will try to understand that there are so many agencies that are involved in the successful execution of the project. If any of these agencies are not able to perform their duty duly, then as a result of that, it may hamper the integrity of the structure, and thus the durability and the service life of the structure may be compromised, right? So that is why it is said that crack is basically the complete or incomplete separation of concrete into two or more parts based on the breaking or the fracturing that is taking place. Now, right? So, crack is basically an early indication of the distress that is developed in the structure. As I said, the distress is can be due to several reasons. That is for maybe due to improper design, maybe poor quality of work, maybe due to workmanship. Then it may be due to early removal of formwork. Then it may be due to overloading, maybe due to the site conditions also, soil conditions also. There are so material issues also, quality of the material that is used on the site, availability of skilled labor is not there, proper site supervision is not there, right? So tight competition in the market is also one of the reasons where the contractors try to bid for the project at a very competitive rates, and then they are not able to fulfill their target, and as a result of that, in order to what we can say extract the profit from their bidding amount, they try and do all kind of malpractices in the construction industry, right? So when you talk about this particular thing, then due to all all these activities that are going to be there, the distress is going to be introduced in the structure, and whenever the distress is going to be introduced in the structure, the indication is going to be there in the form of either cracks or either in the form of deflection, right? So that is why it is said that crack is going to be an early indication of the distress in the structure. Now, it is important to note over here that the cracks may be visible in nature, but when you visualize these cracks on the surface, then it is not necessary that this indication of the crack is going to be a cause of worry always, because you need to identify whether the crack is going to be a structural crack or non-structural crack. If it is going to be a structural crack, then the possibility is there that it is going to dampen the safety of the structure. But if it is a non-structural crack, then only it will be an issue of aesthetic, and it will not compromise on the safety or the service life of the structure, right? So it is saying that the visualization of cracks is normal, but what is not normal is that if you are going to see too much amount of crack, that is the magnitude of the cracks, the depth of the crack, the width of the crack, the spacing of the cracks is very close to each other, then in that case the possibility is there that it is going to have an effect on the service life of the structure, or you can say the structure stability of the structure in overall, right? So if you talk about that, the cracks are going to affect the building aesthetics, and it also destroys the integrity of the structure. Also, it may affect the service life of the structure and the performance of the structure overall, right? So after seeing this basic definition of crack, as I said that it is just on the visualization of the crack, you cannot decide whether this particular crack is going to be harmful for the service life of the structure. First, you need to understand the type of the crack. In order to understand the type of the crack, you should be well aware with the classification of the crack also. So here in case of classification of the crack, first of all, The classification is bifurcated into two. First is the structural crack and second is the non-structural. Now, as the name itself is suggesting, structural crack is something where it is going to have an effect on the structural stability of the structure or the integrity of the structure itself, or you can say the performance of the structure. And non-structural crack is going to be the structural crack. Non-structural crack is going to be the crack which is not being seen in which will not be usually seen in case of structural. For example, if the structure is going to be a frame structure, then if the cracks are visible in case of partition walls, then that particular crack will be classified as a non-structural crack. Why? Because you don't observe the cracks in the beams, columns, slabs, right? So it can be considered as a non-structural crack. And depending upon the location of the crack in these elements, that is beams, columns, and slab in a frame structure, it can be classified as a structural crack, also known as non-structural crack. So two things are important. First thing is that in which element the crack is occurring, that is also important. What is the location of this particular crack, that is also important to understand whether the crack can be classified as a structural crack or non-structural. However, if we look at the reasons due to which the structural cracks can be there, there can be several reasons, but if we list down only three basic reasons, then the first is the incorrect design, second is the faulty construction practices, and third is the overloading, right? So when we talk about the incorrect design, then incorrect design can be done at the office level by the structure engineer itself by not considering the correct loads, by not conforming with the Indian codal provisions that is there, by underestimating the value of the earthquake zones, or underestimating the values of the physical properties of the materials, that is the steel and the concrete, right? So the first of all reason, for the prima facie reason for structural cracks, can be attributed to incorrect design. Second is faulty construction. Now there are so many reasons that can be listed down over here under the category of faulty construction, and that we will discuss in the upcoming lectures as well. And third is the overloading. That is, for if there is going to be a change in the, what you can say, the visibility or the occupancy of the structure, right? Then the possibility of overloading is going to be there. If the change in occupancy is not there, but still due to the construction events also, if the overloading of material is done, then also the possibility is that due to this unaccounted load, the cracking in the structure or the cracking in the element is going to be easy. So these are three prima facie reasons which can be attributed to the structural crack. And if we talk about the non-structural cracks, then in case of non-structural cracks, it is basically due to the internal stresses that will develop due to the building material, right? And we talk about building materials, and building materials basically will consist of cement, sand, and the aggregate, right? So that is why if you look at the definition of the structural cracks, so structural cracks are the cracks which result from the incorrect design or the faulty construction or overloading, and these may endanger the safety of the building. Why? Because as I said, that depending upon the location, if these cracks are going to be identified as structural cracks, then it will be, next question will be whether the failure that is likely to happen due to this crack is going to be a local failure or it is going to be a global failure. If it is going to be a local failure, then the loss of property and loss of life is going to be restricted. But if it is going to be a global failure, then in that case the loss of life and loss of property is going to be in huge numbers, and that has to be avoided, as Indian codal provision is clearly telling that under no situation, under no case, the collapse of the structure is going to be permitted, right? Then when you talk about the non-structural cracks, then non-structural cracks occurs mostly due to the internally induced stresses in the building material. These cracks normally do not endanger the safety, but may look ugly, or you can say unesthetic on the surface of the concrete, and may result that you may feel a little bit worrisome on seeing these cracks, but in actual case these cracks are not going to be harmful to the safety of the structure, or it is not going to cause a major loss to the life and the property of the residents. Now, second type of classification, that is the first classification, was based on the, what you can say, the whether it is the crack is occurring in structural members or non-structural members. Second type of classification is more related to the construction practice. So that is why classification based on the hardening of the concrete. So we all know that whenever this process of concrete is there, then in that case what happens is that the first of all, the heat of hydration is generated when cement and water come in contact with each other, and then as a result of this, the binding material of concrete is formed, right? And when this freshly placed concrete is there in front of you, it is going to be in the plastic state, and later on, after some point of time, when the concrete will start settling down, then as a result of that, it will occupy the hardened. So that is why the classification here is done in case of two categories. First is the before hardening stage, and second is the after hardening. In case of before hardening stage, two things are mentioned, or two categories are mentioned, where the first is the plastic stage and second is the construction, right? So whenever the concrete is going to be freshly placed, so at that particular time some events may take place as a result of where surface cracks may appear, and at that same time the construction movement is also taking place of the equipment, of the labors, of the materials, of the formwork, right? So as a result of these construction movements also, the possibility is that some cracks may be induced at the very early stage of the casting or the early stage of concreting itself. And second category is once the concrete is settled, that is after the setting time of the concrete is done, then after it starts to become hard. Once it becomes once it becomes to become hard, then after that the classification after hardening can be done into the first is the physical, second is the chemical, third is the thermal, and fourth is the structural. So four reasons can be attributed to cracks in the concrete surface after hardening. Where the first reason is the physical cracks, second is going to be the chemical, third is going to be the thermal, and fourth is the structural reason. When you talk about the physical reason, then it is going to be taking into consideration the drying, shrinkage, and the grazing. When you talk about the chemical aspect, it is going to include the corrosion of reinforcement and alkali silica reaction, which we have already discussed in the case of durability of concrete, and how important it is important for us to maintain the durability of the concrete, that we have discussed in detail. Then we talk about thermal also, that also we have discussed under the category of durability of concrete, where freezing and thawing cycles are there. Then along with that, the variation in the temperature is going to be there. Relative humidity is also going to be there. High wind velocity is also going to create a problem, and as a result of it, the cracks may appear on the surface of the concrete. And last is structural, where creep and overloading are the two important factors, as a result of which the strain may be developed in the structural members, and sustained and having a sustained loading over a longer period of time may result into cracks in the structure, right? So this is the classification based on the hardening of the concrete. Now in this particular lecture we are going to discuss regarding the first aspect, that is the before hardening part, wherein we talk about the plastic shrinkage cracks, right? Because as I said that due to this plastic stage of the due to this plastic stage of the concrete also, the possibility is that due to some movement that is taking place, the cracks may be appearing on the surface of the concrete at the very initial. So let us try and understand what is this plastic shrinkage and what are the cause and remedial measures that can be adopted to ensure that this event does not take place on our side. Right. So when you talk about plastic shrinkage cracks, so plastic shrinkage cracks are the cracks caused in concrete, most commonly on the exposed surfaces, that is a large surfaces of slabs, where the movement of the moisture is going to take place over a period of time. Right. When the freshly placed concrete is going to be there, then after the freshly placed concrete is placed, then as a result of that, some kind of moisture movement may take place, and as a result of this moisture movement from the surface of the slab, the plastic shrinkage cracks may be initiated. Right? Plastic shrinkage cracks usually are the cracks that occur before the finishing stage. That is, they occur between the placing and the finishing stage. Right? So once the concrete is placed and before the finishing is done and the curing is done, between these two stages, the occurrence of plastic shrinkage cracks is likely to be possible. So when moisture evaporates from the surface of the freshly placed concrete faster than the case faster than the other case, then as a result of that, the plastic shrinkage cracks are likely to be there. In most cracks, these cracks are wider at the surface. They may be ranging from few centimeters to meters of length, and basically the spacing of these cracks may be 3 meters apart, up to 3 meters apart, or more also in that case. So if you look at this particular figure over here, which is indicating the failure pattern that you may observe on the surface of the concrete in case of plastic shrinkage cracks, is somewhat like this, where you can say that these sparsely spaced cracks are there, which are going to be wide at the surface, and these are going to be up to 3 meters apart from each other, and it can be a few centimeters in length as well. Now, if we talk about the causes, or we try to understand the cause, then as I explained, that the major cause of cracks that occur due to the plastic shrinkage stage is because of the loss of water. That is, the evaporation of the water from the surface of the concrete before the curing period is initiated. Now, what can be the reasons? Then the reason that is mentioned over here is that when the loss of water from the surface of concrete is faster than the migration of water from the interior region to the surface, then in that case, as a result of that, due to this loss of moisture, the cracks may appear on the surface. It depends upon the rate of evaporation of water from the surface of the concrete. So when you talk about rate of evaporation, then rate of evaporation is basically going to be hugely what you can say dependent upon couple of parameters. Which are these parameters? That is, if the temperature of the air above the concrete is high, then in that case you can expect that rate of evaporation is going to be faster. That is, for example, we can take the example of you're doing the concrete casting in summer, and that too at that period of a time in the day where the temperature is beyond 45 degrees Celsius or somewhat like that. Then in that case, it is expected that once the freshly pressed concrete is there on the surface, then it is going to be in direct contact with the atmosphere, and as a result of this high temperature that is there, where the wind is having very high temperature also, and the air is also having high temperature, and as a result of that, the possibility of rate of evaporation is going to be faster than the regular. Then low relative humidity is also going to be there. If there is going to be less amount of moisture in the humidity in the surrounding atmosphere, then in that case also it will try to extract moisture from the surface of the concrete, and it may also result into the problem. And lastly, if the wind velocity is that is if the there is high amount of wind that is passing by, then as a result of that, and if the wind speed is more also at elevated heights, then in that case also the possibility is that due to this strong wind motion that is going to be there, the evaporation of moisture from the surface is likely to be there, right? So basically, you can attribute the main cause of these cracks that are appearing due to plastic shrinkage to the rate of evaporation from the surface of the concrete. Now, lastly, the question comes is what can be the preventive measure? Then the preventive measure is very simple. That is, if you try and control the movement of the moisture, or if you try and restrict the movement of the moisture from the surface of the concrete, then as a result of that, you can avoid the plastic shrinkage. Now the question comes is how we can avoid this movement of the moisture. Then the first thing is that you can moist the formwork itself, because when you are knowing that you are going to do the casting in elevated temperatures, then it is necessary that you soak up the aggregates also, and at the same time you should also sprinkle the formwork also, so that it is not going to try and absorb the water or absorb the moisture from the surrounding concrete. Because if the temperature of the surrounding formwork is going to be high itself, due to this high temperature, then as a result of that, it is going to absorb the moisture from the surrounding concrete. So first and foremost thing that you can do on the site is you can moist the formwork. Second is erect temporary wind braces. As I said that when the wind velocity is going to be high, then in that case also rate of evaporation is greater. So in order to reduce this direct contact of the wind velocity with the surface of the concrete, one of the things that you can do is you can install the wind barrier. Wind barriers can be in terms of polythene sheet also. Then we have also discussed that if the temperature is high or the relative humidity is low, then in that case also the possibility of cracks is there. So in that case, you can erect temporary roofs also, or you can use polythene sheets also to cover the surface of the slabs when the casting is done, in order to avoid the movement of moisture from the surface, right? So these are all practical aspects that you can, or practical what you can say points that you can take into consideration when the freshly placed concrete is there on the surface. And at the same time, you can use some bonding agents also, as it is mentioned over here, in order to control the movement of the moisture from the surface during these times when these temperature changes are going to be there, or thermal changes are going to be there, right? So I hope that the classification of the crack, along with that the reasons attributed to the plastic shrinkage of cracks, and how the preventive measures that we can take in order to control the movement of the moisture from the surface is clearly understood to you. And it is expected that now whenever we are supervising any particular thing on the site, then in that case we take into consideration these measures and adopt them, so that the plastic shrinkage on site can be avoided. I hope you have enjoyed today's lecture. Stay tuned for the further lecture series.